Welcome to my movie about the centripetal force. Well, I'll start with the movie of myself. I have here a cork on a string and I start rotating it. And when I go faster and faster, I need to exert more force to keep the object on the circular motion. Oops, and when I let it go, it leaves the motion in a straight line with the velocity at the moment I let it go. So, let's look at it. So I have a circle. Let's take the laser pointer. I have here a circular path with a radius of r, and the object here, which is here positioned here, has a velocity of v. But at that moment, to keep it on the circular trajectory, I need an acceleration towards the center. Otherwise, I would go in a straight path away at the moment where my my centripetal acceleration would not be present anymore. Then I would go in a straight trajectory away. We have an acceleration perpendicular to the speed. A constant circular motion, the acceleration is given by this formula. The acceleration is r times omega square, which is the same as v, the speed, the trajectory speed. This is a circular motion speed. V squared divided by the radius. We also know Newton's second law, which says the force is the mass times the acceleration, the net force, which together brings us to a formula for the centripetal force, which is in fact m times r times omega squared equals the mass times speed squared divided by r. So now we can calculate this. One important thing, I go back a little, is that this force is not the same like let's say gravity or frictional force. This is in fact a form of a net force. So a resulting force or a net force can take the form of centripetal force. The centripetal force needs to be caused by something. It's not like there's a magical force somewhere at work to keep my cork on the circular path. In this case, it's the tension which I exert with the string, which gives, in fact, because it's the only force at that moment on the cork, which gives its circular motion. So it's the tension in the string which gives the force I need, which is the centripetal force, my net force I need. Let's do it in an example. Calculate the tension in the rope when I make 2 revolutions per second. The length of the rope is 30 centimeters. The cork has a mass of 50 grams. Given is a frequency of 2 Hz, 2 revolutions per second, a radius of 30 centimeters, which is 0.30 meters, a mass of 50 grams, which is 50 times 10 to the power minus 3 kilogram, and we need to find is the centripetal force. So the solution is we use this formula because we know that omega is 2 times pi times f, the frequency. Makes us formula m times r times, and then our formula for omega. In squared we fill everything in, 50 times 10 to the power minus 3 kilogram, 0.30 meters, and 2 pi 2.0 Hertz. And that squared gives us 2.4 Newton.